function in R. AOV function is going to perform an ANOVA for us. So first things first, let's get our data. So we're going to look at the student survey data set from the Locke textbook. Now, the student survey data set contains a lot of information. For an ANOVA, we need a variable that is a continuous variable. That will be our response as we are looking for means. So we might consider something like height or weight in this case. We also need a categorical variable that we can use as our grouping variable. Therefore, perhaps we can consider the type of award a student would like to win. So let's consider those. We want to perform an ANOVA, so we're going to use the AOV function. Now, our two variables that we want to use, our continuous variable and our categorical variable, need to go in our function. And we're going to use the function or equation notation, rather, in AOV. So we're going to put our continuous variable first. So I will type in height, then we do our tilde, and then the variable we wish to perform our ANOVA on, award. Now, in order to use these variables in this way, we also need to specify the data set that they are coming from. So we will have our student survey data set. Now, if we run this code in R, we're going to get some output. And it may or may not be terribly helpful to us. You can use these values, sums of squares, degrees of freedom. These are the values you need in order to calculate the mean square for error, your mean square for group, your F statistic, and p-value. However, R can do all of this for us. So instead of just running this line of code, let's give it a name. Let's save this value. So I'm going to call this my AOV. Now if we run this and save it as my AOV, now we can run other functions on this object that we have created. And the first one is the summary function. Now if I run summary on this, now I get something that probably looks a little more familiar. We have our grouping variable and we have our error line and our full ANOVA table as we may be more used to seeing. Additionally, R is going to give us this little key over here to indicate if our result may be significant. Now with ANOVA, one other thing we want to consider are our assumptions. Now R is built very well with the function plot on our object we've created, which we can use to check these assumptions. So if I run plot, R is going to wait for me to come up here and hit enter or return so that it knows I'm ready for the next one. And then I'm going to get my plots down here. Now this first plot is one that we can use to check for constant variance or equality of variance across our groups. We want to look at the height or the spread of these various lines that are created. Now note for this data set, this is going to be a little interesting. We notice some of these circles are darker than others. That's because our heights are limited to specific inches. So there's going to be some break off here. Now, in general, we can look at this and see no one bar looks to be twice that of another, so our quality of variance looks pretty good. We can then go to our next plot, and this is where we're going to check for normality. Again, in general, we want to see our points close to our reference line. There's definitely a little bit down here we would call a tail, maybe an outlier up here, and again, due to the nature of the data we're looking at, we see kind of horizontal bars across here, which is a little strange, but in general, I would look at this and say, this is probably acceptable. There are two more plots that are generated. We haven't considered those much for our class, so we're not going to consider them much here. So hopefully this helps you with ANOVA.